Hello, class. Dr. V here. Today we're going to work on graphing systems of linear equations, okay? And really, the big question is we're going to be leading into why is it that mathematicians take it upon themselves to adjust and adapt equations in order to solve larger problems. And hopefully at the end of today's lesson, you'll see that. So what I'm going to do is I'm going to go ahead and switch over and we'll do a quick warm-up exercise. And I'm going to switch screens here real quick. Okay, so you should see my picture in the upper corner. If you don't, please holler at me and let me know, okay? I don't literally mean holler, but just let me know, all right? Okay, first thing, this is a review of what we did before, okay? And typically, I would give you some time to work this out, okay? But I am recording this lesson for a group of folks that are going to be evaluating me, so I'm going to go ahead and say that I gave the students, a quick, 3 minutes to 4 minutes to go ahead and solve this equation. And what I would be looking for is for them to put it into the y equal mx plus b form, also known as point slope form. Point slope form. Okie dokie. All right. So we would want to see you, and so now I'm reviewing as I'm speaking to students. So you would go as such, okay, and hopefully we can have one of the students demonstrate their correct response. And this would have been a review of what we've done before. Some of you may think it's okay to do that, and it is perfectly fine. But we always like to put it in what we call in mathematics prescribed format. Although you'll find that when you do statistics, you will see different forms out there of what this will look like. Sometimes you'll see it this way, and sometimes you see it the other way. But right now, we're going to work with it in the format where we're going to put the slope first, because we want to be consistent with this up here, right? So we're going to put the negative 4x plus 2. And again, as we discussed the last 2 days in our lessons, the slope here is negative 4 over 1. Okay, it's a rate of change of negative 4. So you would expect the graph for this to be a line moving in the downward direction from left to right with a y-intercept right here of 0, 2. So we're going to go ahead and go to our graph, and your 2 is right, 0, 2 is right here. See where I'm penciling it right there? That's my 0, 2. So that is this part right here. And this is why we love this equation, because now the only thing I need from there is another point to draw a straight line. And I know my slope is negative 4. So you can do this going up and left or down and right. That's up to you. If I go up and left, I'm going to count up 4 spaces, 1, 2, 3, 4, and 1 to the left. Because my slope, my m, is equal to negative 4, which is the same thing as negative 4 over 1. And remember, the top is what we call the rise, and this is the run, right? The rise is also known as the change in x, and the run is the change in, the rise is the change in y, and the run is the change in x. All you need is 2 points to draw your straight line, and then you're golden. But if you want to do another third one just to feel more secure about it, that's perfectly fine. 2, 3, 4, and 1 to the right. And this is what your line should look like. These 3 dots put together. And let's see if I can get a straight line out of this. All right. All right, here's my line. And let me run the line. Oh, sorry about that. Okay. There you go. An easier way to do it is we do have the Desmos tool. Okay, so I'm going to go ahead and switch to Desmos. Let's see here. Here's the Desmos tool. And I went ahead and already graphed it. Notice that the line up here is 4x plus y equal 2, which is the original equation, right? Which is rather interesting how the line comes out that way when you use Desmos. And if you wanted to do it with another one the same way, just say y equal negative 4x plus 2. You get the same exact line. You see that? And this one is something that's easier to graph because you can see where the intercepts are there, whereas here you can't. And now in today's lesson, what we're going to do is we're going to go ahead and see what happens when we want to do another equation so that it becomes part of a system of equations. Okay, that's our opening activity. So go ahead and take a few minutes, and you can use Desmos or you can use your hand method if you wish, your notepad, and go ahead and see if you can graph the second one, the 2x minus 2y equals 6. Okay, so for you guys that are observing out there, basically what I would give the students a few minutes and do a quick check to see how everyone's doing. And probably what I would do is demonstrate for them the graph and then maybe do something like a poll to find out how many students had the correct graph. Okay, just to make sure that we're not going to be moving too far and too deep without adequate time on the making sure the students can do that. So we're going to go ahead and walk the students through. So I'll do a quick review. I said, so as I showed you on the on my hand calculation, we subtracted the monomial 4x from both sides, and we wound up with y equals negative 4x plus 2. With this one, it should have been a little bit more challenging. At this point in time, I would ask the students what was challenging about it. There was multiple strategies for this. You can divide through by 2 first to make life a lot easier that way. And or you could follow the I could pose that I can do this first, pose the question to the students and say, okay, you have negative 2y equals negative 2x plus 6. What can we do here? And the answer would be, of course, divide by 2, negative 2, because you're trying to isolate y. So we divide by negative 2 on both sides, and we get y equals negative 1x minus 3. Could we have done the reduction prior to the operation? The answer is yes, you could have, because this equal sign means that everything is in balance here. So therefore, if I have a 2, 2, and a 6, my greatest common factor or greatest common divisor is going to be the 2. So I can do that, okay? But here's my next one. My slope is 1. My intercept is negative 3. So now let's graph them. Okay, and notice that what does it mean when the 2 points intersect? Well, they're intersecting at point 1, negative 2. notice what happens when you take a 1 for x and a -2 for y, and you plug it in here. What do you get? Well, let's go back to my grid and I'll show you. -1, 1 and -2. Okay. All right. So we said the solution was 1, -2. That means that your x value is a 1 and your y is -2. Okay. So if your equation was the original equation was 4x plus y equal 2, you'll notice that 4x plus y equal 2, 4 times 1 plus -2 equal 2, 2 equals 2. Check. Okay. So 1, -2 is a solution. It's a point on that line. And you will find a similar situation with the other equation, which was 2x minus 2y equal 6. And our point was 1, -2. So here we go, 2 times 1 minus 2 times -2 equals 6. 2, negative times a negative is a positive. 6 equals 6. Check. Okay, so it works out quite nicely that way. And, you know, the big idea is what? Well, with your partner, what I'd like you to do is come up with the big idea about how and why mathematicians manipulate equations. And what I'd like you to do is write out your thought. So the first thing, before you meet up with your partner, I want you to take a minute and just write a sentence on your own, 1 or 2 sentences on your own, as to why mathematicians manipulate equations. Okay, I don't want you to talk yet. I want you to just take a couple of minutes, and I'm going to time you, okay? You're going to have 3 minutes or 4 minutes, and I want you to write that out. Write out your thought on that. Okay, go. All right, so now the students are writing. At 3 minutes, I would check on them, say, you know, a few more seconds for you to finish up your statement. Okay, now what I'd like you to do is real quick, do a think, pair, share, okay, and share your idea with your partner, okay? And eventually what I'd want the students to do is on their own for them to know that when I say, or when we do this in class, when I say, I want you to share with your partner, what that means is that they should take some time to reflect on their own first prior to externally processing. The external processing is, I'm an external processor, and I know that quite a few students are, but not all students are. Some students are internal processors and they need time to think it out. So it's a good strategy to, if you're not a external processor, for you to get into that mode. And then if you're not an internal processor, for you to practice that. Okay, so that's basically it. And then as a cool down activity, what I'll probably do is, since the next idea is the big idea here was mathematicians rewrite systems of equations in slope-intercept form to easily graph them and find their solutions. Okay. If we're going to let students use Desmos in 2023, that's going to be probably what I'll hear some students ask. Okay, and then now here's where the students would develop the concept, okay? Concept development. determine the solution. They would work it out just like this. So this would be another lesson that they will work on. But you'll notice that it's the same exact thing. This is something we would have done in class. I wouldn't do the cool down yet. Okay, so that would be the practice right there. And then the second concept, I believe this is the one with the, is this the parallel one? Let's see. Yeah, this is the one with the parallel lines. So now we start to discuss this idea of parallelism, okay, as to with what do they notice is different, what do they notice is the same with the two lines, and some students will respond that the lines are moving in the same direction, they're just not touching. Other students may use the word parallel, and some students might actually notice the 1/2 slope is the same for both, but that they intercept at different points, okay? And all of those are valid observations, and we just kind of put them all together, and we say that these are the properties you have just stated, the properties of linear equations that are parallel to each other. Therefore, since we said before that when they intersect, that the solution is where they intersect, what can this tell you about the solution? And what we're trying to get to, of course, is that parallel lines have no solutions. Okay, there's no solution. Okay. And then the big idea, again, rewriting equations so you can observe in the format of the equation, you can see the patterns. That's where we want to go with that. So anyway, that is my presentation, and I hope you liked it, and I hope that I move forward in the process. So take care, and I hope to hear from you soon. Bye now.